Hello students, today in your algebra class we're going to be working on multiplying special cases. So at the end of this lesson you should be able to solve special cases of multiplying binomials. Now there are a couple of rules that we're going to take a look at. The first one is if you have some number a or b, so a plus b, and you take that quantity of square it. When you do that you can easily simplify it to a squared plus 2 times ab plus b squared. And the bottom one, or the second one, is a minus b quantity squared. The way you can simplify that one is to square the first one, which is a, so a squared. You square the second one, which is b squared. And for the middle, you're multiplying a and negative b and multiplying that by 2, or you're doubling it. Now, I typically don't tend to memorize these rules, but I wanted to make sure we show them to you because as you go through expanding or simplifying these types of problems, you should start to see a pattern. The last one is called the difference of squares. And it's called the difference of squares because if you look at it, after the equal sign, you have a squared minus b squared. So really you have the difference, the subtraction of these two squares, or the difference of two squares. And what happens is when we see it multiplied as two binomials, it's a plus b times the quantity a minus b. So notice they look exactly the same, but different sign. So we're going to practice a couple of them together, and to help, we're going to take out these rules. Now, the rule 1 helps us with example 1. What we have here is we have x plus 7 quantity squared. So, we have x plus 7 quantity squared. So, based off of the formula, we take x and we square it. We take the last term, which is b, or 7, and we square it. And in between those two things, we're going to put 2 times a and b, which is 7. So really what you're looking at here is x squared plus 14x plus 49. So that's all for that one. For example 2, I want to make sure we still stress this. This is saying 2x plus 3 times quantity 2x plus 3. And when you expand it, either using the formula or using FOIL, you would end up getting 4x squared plus 12x plus 9. Example 4, same idea but with a minus sign. We have x minus 4 times quantity x minus 4, and you would end up with x squared minus 8x plus 16. Again, using the same exact rules or just using FOIL like we've done. You'll notice example 4 is a difference of two squares, because notice it's the same exact thing but the signs are different. So you would end up with x squared plus 3x minus 3x minus 9. So notice that when we do the FOIL method like I did here, the 3x and the negative 3x end up canceling, and you're left with x squared minus 9. Example 5, it's the same kind of idea, but in this case, I'm asking you to find the area of the shaded region. So this should be fairly easy. All we're doing here is we're finding the area of the entire square, which in this case is x plus 4 quantity squared. That's the area of the entire square. The only thing is we don't want the area of the white portion or the white square. So we're going to subtract 2x times 2x or 2x quantity squared. And we're going to work on solving that right now. So x plus 4 quantity squared turns out to be x squared plus 8x plus 16 minus 4x squared. That leaves us with negative 3x squared plus 8x plus 16. Now it's your turn. Try solving these 3 problems, put them on your notes, and we'll take a look at them in class. That's all for now. I'll see you guys next time.